Bridges, section 8.4, graphs of quadratic functions. So far, we've been working with quadratic functions that are in general form. In other words, f of x equals ax squared plus bx plus c. So that's general form. There's another form for these things. It's called standard form or vertex form. It looks like f of x equals a times the quantity x minus h squared plus k. So this is called standard form or vertex form. And the reason why it's sometimes called vertex form is because you can look at it and immediately tell where the vertex is. So the vertex is at h comma k. So notice that this h here has a minus in with it. So basically you have to change the sign on the h part and leave the sign alone on the k part. Because we know, based on our experience, that when you graph a parabola, or excuse me, when you graph a quadratic, you're going to get a parabola. And that parabola has a vertex. That's that low point where it changes direction. So, and every parabola is symmetric about its axis of symmetry. And the axis of symmetry, or just the axis, would be x equals h. So it's the vertical line that goes through the vertex. Now, if a is positive, then your parabola opens upward. And of course, this point down here would be the vertex. And that would, of course, be a low point or a minimum. If, on the other hand, a is negative, then that causes your parabola to flip over. So this would open downward. And then your vertex would be up here as a maximum point. So, that works really well. But a lot of times your vertex isn't, or your equation isn't in vertex form. So if that's the case, so if f of x equals ax squared plus bx plus c, then the vertex is at x equals negative b over 2a, and y equals f of negative b over 2a. In other words, once you figure out the x, you plug it into the function to get the y. So let's practice at this. Find the vertex. So let's say I have f of x equals x squared minus 6x plus 5. So at this point, what I would do is I would say, okay, x equals negative b over 2a. In this case, b is negative 6, so negative b would be positive 6. And of course, a is 1. This would come out to be 3. And then to get the y coordinate, I would say y equals f of 3. So I would plug in 3. So this would be 3 squared minus 6 times 3 plus 5. So that would be 9 minus 18 is negative 9, plus 5 is negative 4. So the vertex would be 3, negative 4. And of course, then the axis of symmetry would be x equals 3. All right, let's do another one. And this time, what we're going to do is we're going to add on a little bit. Once we find the vertex, we're going to try to graph this thing. So, this time I'm going to have f of x equals 3x squared minus 9x. So if I want to find the vertex, I guess we should probably get a grid here. There's my grid, so let's find the vertex first. Negative b over 2a, so that would be 9 over 2 times 3. 9 over 6 reduces to 3 halves. So then y would equal f of 3 halves, which would be 3 times 3 halves squared minus 9 times 3 halves. So let's see, 3 halves squared would be 9 over 4 times 3 would be 27 over 4 minus 9 times 3 is 27, so 27 over 2, which would be negative 27 over 4. So the vertex would be 3 halves, negative 27 over 4. Now, in order to graph that, it would probably be good if we had a decimal approximation for these sorts of things. So 3 halves, if I take 3 and divide it by 2, I get 1.5. So this is like 1.5. And then negative 27 over 4, if I divide 27 by 4, I get, this would be negative 6.75. So 1.5, negative 6 3/4. So there's 1.5 and 2, 3, 4, 5, 6. That'll be roughly there, give or take. The axis of symmetry would be x equals 3 halves. So literally that is, where is my hangout? I apologize if you're a bit disoriented. My software crashed there for a moment. I had to try to recover this page, and I couldn't remember exactly what I wrote on it, so I have to make it work. But anyway, so what I was going to do was show you that the axis of symmetry is this vertical line that goes right here. Okay. Now, in order to graph this better, it would probably help if I knew the x-intercept and the y-intercept. So to get the x-intercepts, what I'm going to do is I'm going to set this equal to 0. So to get the x-intercepts, I'm going to do f of x equals 0. So 0 equals 3x squared minus 9x. And how you solve that, I mean, there are several different ways you can solve that. We just finished taking a test over this. Basically, you can factor this, right? So 0 equals, now there's a common factor of 3x, and then that would make this x minus 3. So my solutions would be x equals 0 or x equals 3. So notice that I can plot those on the x-axis. So there's 0 and there's 3. And if you look back at the axis of symmetry, if I redraw it, you'll notice that that's symmetric about the axis of symmetry. So these are centered about that axis of symmetry. I guess it disappeared. But anyway, so what I can do is I can just make this into a parabola like so. All right, let's do another one that's similar. I'd like to sketch y equals x squared plus 6x plus 8. All right. Now, let's find the vertex. So to get the vertex, I'm going to use x equals negative b over 2a. So that'd be negative 6 over 2 times 1, which would be negative 3. And my y is what I get when I plug in negative 3. So this is negative 3 squared plus 6 times negative 3 plus 8. 9 minus 18 is negative 9 plus 8 is negative 1. So the vertex would be negative 3, negative 1. So that'd be that point right there. The axis of symmetry would be x equals negative 3. And then to figure out the x-intercepts, I'm going to take y and set it equal to 0. So 0 equals x squared plus 6x plus 8. If you notice, this one is factorable. So this is x plus 2, x plus 4. In other words, x equals negative 2 or x equals negative 4. So if I plot those, one of them's there and one of them's there. Now, in order to get an even better picture of this, let's get the y-intercept. So the y-intercept is what you get when you plug in 0 for x. So y equals 0 squared plus 6 times 0 plus 8. That would be 8. So I can come up here on the y-axis and plot 8. Now here's where I'm going to take advantage of the axis of symmetry. Because remember, the axis of symmetry is right here. So what I'm going to do is I'm going to create the mirror image of the y-intercept across that axis of symmetry. So since it's 3 away, I'm going to go 3 away to the other side, which would be here. And then I'm going to draw my parabola like so.